they can just ask. So you didn't need to be just prepared. Just remember, if it's a non-linear graph, how do you know? They will say maybe draw a line of best fit. Maybe they don't say straight line. In the question, of course, you can't go and find the gradient or y-intercept lah, isn't it? So what they might ask you to find, maybe they might ask you to find gradient at a particular point, because you need to learn how to take tangent of a curved line, right? Gradient of a tangent of a gradient of the tangent on a curved line, isn't it? I'm sure you got learned in geography, mathematics, history, or so you got learned, isn't it? Otherwise, you can go and ask the student. He said, I'm a maths person. Who's that? Can ask how to do that. Okay. So another type of question they may ask, find the maximum value or minimum value. So maximum, minimum is for curve, isn't it? Can be, they can ask. Just be prepared mentally lah. You wouldn't know what they might ask. Don't always think they'll ask a straight line. Okay? Clear? Yes. Some more anything about yesterday's experiment? No? Okay. Shall we continue with our lesson? Okay, we have done wave. I will discuss the question next week, Tuesday. So Tuesday is our tutorial. We'll discuss questions and all that on wave and other chapters before that. So I want you to make sure you finish doing your papers. Okay, guys. Your exam is in when? In June, is it? Your exam is 2 weeks. When is your semester exam? 30th May to 11 June. Yes. Okay. 30th May to 11 June. So it's, yeah, correct. I think the last day of the exam is 10th. Right? So 30th May to 11 June. 10 June. 10 June is Friday. So it's be going on for 2 weeks. Now for the exam, you will have paper 1 and paper 2. There's no paper 3. This is a semester exam. There's no paper 3. Paper 3, there'll be only for trial exam. Okay. So there'll be paper 1 and paper 2. Paper 1 is MCQ, 40 question, 1 hour, 15 minutes. We follow the format of the exam paper lah. Paper 2 also is 1 hour, 15 minutes. So paper 1 is 40 marks, paper 2, 60 marks. Both marks will be added. Right? Make sure you prepare well for the exam. Right? Make sure you prepare well for the exam. All right? So let me pause. I want to tell you something. And standing wave. First, we learn about superposition. Then we learn about standing wave. Now, before we look at this chapter, we need to learn something about, we need to know about the phenomena of wave. What you consider, how you consider a wave as a wave. That's most important. Okay, what makes a wave is that it must have these 4 phenomena. Number 1, reflection, which you already learned, okay, in IGCSE and in SPM. Reflection obeys the law of reflection. The incident angle equals to reflected angle. If you're not sure, when having a revision or tutorial, you ask. If you're not sure, if you don't remember what is reflection. Very seldom they ask about reflection, but you need to know. Second is refraction. Refraction is the bending of wave, right? Bending of wave when the wave propagate from one material to another material of different density. Okay. Number 3 is diffraction. Number 4 is interference. Okay. So in A levels, we're going to learn more about these two. However, there are some part you may see a bit here application, but these are the two things we're going to learn. So first we're going to learn about diffraction. Okay. So diffraction is the spreading of waves as they pass through a narrow slit or around an obstacles. So the spreading of wave as they pass through a narrow slit or around an obstacle. This is the definition of diffraction. So example. So let's say now this is a slit. This is a slit or an aperture. So this is the wave going through now. So the wave now goes through like that. You must learn how to draw this diagram correctly. If you look at the past paper question, a lot of marks are given. Number 1, the wavelength, there's no change. Okay. Wavelength doesn't change. And then the arrow. So this is what we call as a good spreading of wave. So what is the opposite? So let's say now this is the aperture, slit. This is the size of the slit A. This one slice as A is small. So the wave now pass through. So something like that. This one is poor. Poor spreading of wave. Lambda, lambda. So in both cases, lambda remains the same. Speed remains the same. Lambda remains the same. Frequency also remains the same. How about obstacle? This is the obstacle. Like that. Okay. If it's a large obstacle, then you have something like that. This obstacle. So note, no change in lambda, V or frequency. Remains constant. The only thing, the pattern changes in diffraction. That's what happens. So what is the use of diffraction? What is the use of diffraction? So diffraction is mainly applied, example like in a water wave. In water wave, place that you have very strong wave, they will build these walls, okay, to slow down the water wave or to reduce the water's speed and so on. Example, like if you've been to Langkawi, there is a what they call as a wave breaker. Have you seen one? Huh? So if you look, if you've been to Langkawi, where's the yeah, this is the airport here. Is this the airport? Yeah, this is the airport. Okay, maybe we put now better. So this is the airport. Okay. See, do you see wave breaker? You put the wave breaker there. This is the airport. So normally the plane will now move this way lah. So you see the wave breaker they put here. Okay. Why? Why they do that? Why they have a wave breaker? Huh? So the reason is being because you see, if you look at it closely, this is facing open sea. See? So the air and the wave is very strong. So they put wave breaker to allow the diffraction of the wave. So when the diffraction of the wave happens at this point, right? Do they have the picture of it? Looks like this lah, something like this lah. But actually, it's like it's more on like a wall, small wall like that. You won't miss it as you go around the airport, right? So that the diffraction of the wave will slow down the wave as well as the wind, because it can create a crosswind. You see the plane is coming this way, right? So the plane is coming this way and the wind is going this way, right? So the plane may end up in the Sawapadi inside here. We don't want that, isn't it? Crosswind is causing a crosswind. That's the reason. Okay. So that's the use of a wave breaker. Other than that, what else they use the wave breaker for? To diffraction. Okay. I'm not sure whether they have here or not. Where's the okay, like you see here. So this part here, the wave can be quite less because you already have islands protecting them. So the wave here is lesser, less stronger. Okay, same thing when you're having, I think they have a place where they put all the ship at the yacht and all that. A very good method way to explain this. I think somewhere here lah. I think where is it? Oh, there you go. This part here. See? This is where all the ships all will be here. So this is another reason, another good example of diffraction. Okay, that's because you see you have a small opening here. So when the wave is now moving, right, it's coming through here, the wave will get diffraction. So you have all the small ships, all they can park here, isn't it? They can put the ship there, right? They can leave the ship there so it won't be affected. If you put in the opens, you put the ship here, or you put your boat here, your luxury boat over here, you put there, next day you come in and missing. Don't know where you went because the wave is strong. But over here, the wave is less. So this is how it's applied lah. That's what I'm trying to explain. Okay, can understand? Anything you want to ask?
Sir, more diffraction means stronger wave or less, the poor spreading?
More diffraction, this is a good diffraction. There's no more. This is a good diffraction and there's a poor diffraction. So the good diffraction means good lah. The energy is spread out. Energy is spread out like that. Clear?
Yeah.
Let's move on. Next part. Next we look at the principle of superposition. So the principle of superposition is the most important principle in this chapter, right? And it's very long. When two or more waves of the same type meet at a point, the resultant displacement is the vector sum of the individual displacement of the wave. This is the meaning of principle of superposition. I'll give you an example what this principle states. So when two or more waves of the same type meet at a point, the resultant displacement is the vector sum of the individual displacement of the wave. So what does this mean? Okay, a wave typically like a water wave consists of a crest. This is a crest and this is a throw. Okay, that's what make the wave, when you look at the shadow of the wave, it look bright and dark. I think some of you all saw that yesterday because Ivan was pestering me to show it, right? And the other class didn't get the chance to see, but it's okay. I will show it next week because I want to explain about this first. Then I show next week. But of course, some people cannot wait lah. They're like, I want it now.
No, sir. I could wait.
I didn't say you what.
I can wait.
Why you are admitting that it's you? Okay, let's continue. So you have crest and throw. Okay, you have crest and throw, right? Esther, wind, what you're saying about wind wave?
No, sir. I was asking for the aperture thing above just now.
The wind will simply pass through the aperture, what? There's no wave. There's no wave for wind.
Oh, so this is only for water, is it?
I'm explaining mainly for water and light. Water, light, and sound.
Okay, sir. Thank you.
Water, light, and sound. There's no such thing as a wind wave, Esther. Erase it, remove it from your database.
Okay, sir.
Okay, so you have crest and throw. When you have the crest plus the crest, where the amplitude A is the amplitude, you have 2A. When you have throw minus the throw, you have minus 2A, like that. This is called constructive interference. Constructive interference or maxima. Okay, when you have the crest plus the throw, you get nothing, zero, because A plus minus A, 0. This is called destructive interference. Very simple word or very simple term that they use to describe. And this is minima. So how does this appear for wave, different type of wave? How does the maxima and minima appears? So if you have a maxima, which is a constructive interference, okay, and if you look at for water wave, for maxima you have a bigger wave. Some people say tsunami lah, something like that. If you refer to light, then it appears to be brighter. Sound, it will be louder. Okay. If it's a minima, which is a destructive, then if it's water, the water becomes calm. Calm, no wave lah. Then if it's a light, then it becomes dark at that point. Sound is either no sound or loud.
So shouldn't the sound be soft?
Yeah, sorry man. I just checking lah. Only you are concentrating the class. No wonder you are the class rep. Okay, anything you want to ask based on this? I want to go a bit slow and thorough in this chapter. This one is very challenging chapter in the chapter of waves. So I want to go easy on this slowly until you really understand. Those who don't understand, ask question.
Sir.
Yes?
How do the two different like waves meet in the first place? What exactly happened?
First of all, two different waves cannot meet at the same place. Even they meet, nothing's going to happen. They must be same type of wave. I know you're setting trap for me, Ivan.
Then how did the two same type waves?
How can a two different wave meet at a point? Huh?
I'm not sure. That's why I asked. But
cannot lah. When two different wave, that means light wave meet with the water wave. Are you saying that the effect of superposition is going to happen? No, what?
No, sir. Not like, I mean like the the different types of like the crest and the throat, wherever it is, like when they meet.
How they going to meet? The one I'm going to explain later lah. How they going to meet?
Okay.
How they're going to meet, in what way they're going to meet, and so on, and then how this process is going to happen. Okay, constructive interference, how does this happen is basically, you see here is mathematics. A plus A, what do you get? 2A. Negative A plus negative A, negative 2A. Correct or not? So when you have this is called constructive. This is also called constructive. Okay, isn't it? Example, like this, A plus negative A, 0, nothing. Let me give you an example, different way lah. So example, maybe you have, okay, like this, take a graph, like this wave meet like this. So what you have, this is A, this is negative A, negative A. So what you have is like that, this is negative, this is 2A, amplitude, minus 2A. Like that. So this is constructive. This is constructive interference. Then if like this, now A minus A plus the other way around. Okay. plus like this. Negative A, what's going to happen? This meets this meets this. What's going to happen? Nothing, 0. A plus minus A is 0. Negative A plus A is 0. This is called destructive. Can follow or not?
Sir,
Yeah.
is this when two waves meet?
Yes. This is one wave. This is another wave when they meet.
Okay, thank you, sir.
This is wave 1, wave 2, wave 1, meet with wave 2. When they meet, this is what happens. Okay? Okay, how they meet? You guys can't wait. I will explain how they're going to meet. Which direction they're going to meet. Why all doing the Ivan? So the formation of a point of reinforcement. What is reinforcement? Another word. What is the reinforcement of what is another term for reinforcement? What is happening at that point?
So it's interference, not inference.
Huh?
He's trying to correct you, sir.
He's trying to challenge you.
Interference. Okay.
Hey Ryan, you in Australia? Why are you upside down?
What? Oh yeah.
Gone, man. Where two coherent waves pass each other. That is the meaning of interference. So when the two waves meet at a point, this process or this phenomena is going to happen, the interference, where you might have the cancellation, which is destructive, or reinforcement, which is the constructive. Okay, so conditions for two source interference. What are the two conditions? Then after that, I'll explain what is interference. Number 1, they must meet at a point. They must meet at a point. Of course, if they cannot meet at a point, how does the interference going to happen? Isn't it? Correct or not? Interference, in order for interference to happen, the wave must meet at a particular point. Depends, like this or like this. Got effect 1. So the one you wait, slowly we learn. Number 2, they must be of a same type of wave. Water, sound and sound, light and light lah. Cannot have two different waves lah. And the third is must be a coherent wave. What is the meaning of this coherent wave? Coherent wave is the same type of wave. Coherent wave is the same type of wave having same frequency or constant phase difference. So they have same frequency or same constant phase difference. What is the constant phase difference? I think I've taught you in the earlier chapter. I will reinforce it in this chapter again. right? That is the meaning of interference. Anything on us based on this before I give example?
Sir,
Hmm.
you underlined the reinforcement, that part. What was the other word you said just now?
Reinforcement, or the other word is constructive. Cancellation is destructive lah.
Oh, okay.
Hmm. Okay, so I'm going to give you example of the two source interference. In this case, I'm going to give example is light wave. Wave is two source interference, is called Young's double slit experiment. Young's double slit experiment. Okay, so Young's double slit experiment, this is the two slit where the experiment is A, and you use a light source, monochromatic light source. So this one is a laser. What is a monochromatic light source? It's a single color. Single color meaning it is a coherent light source. Single color, they mean same frequency or wavelength. All right. So this is the double slit. This is called a double slit. And on the screen, what are you going to observe? Right? You're going to observe a fringe pattern. You're going to observe a fringe pattern. Red color la, fringe pattern. Something like this. All right, which has a constant distance of separation between them. Okay, this is the central maxima, right at the center, right? And then there's actually dark band here lah. You can't see anything here. This will be dark. This will be dark, like that, like that. So this is bright. Okay, this is all called fringe pattern. This is bright or maxima or constructive. This one is dark or destructive or minima. This is a pattern you will see. And the distance between here is D. The distance of separation between here to here is X, or from here to here is X. You can take from middle point to midpoint. Okay. You can take from the midpoint to midpoint, or see which way as long you get X. This is what you observe lah on the screen. So the formula that relates A, B, and X is this formula. Lambda equals to AX over B. This is the formula. Where lambda is the wavelength, X is the distance of separation between adjacent maximas or minimas. Okay, D is the distance between double slit and screen, and A is the distance between the two slits, which is approximately 0.3 millimeters. This one you have to memorize. Question I've asked you to give you some sort of estimation between the slits. Okay. Example, I'm going to show you example of how the double slit experiment look like. So this is the double slit. This is how the fringe pattern. This is how the fringe pattern look like. You see the colors. This is the best. This is the fringe pattern look like. Red color, green, and this one look like a violet. Do you see the difference? Why the difference? Why red is further apart? Why the green is getting shorter? Why the blue is getting shorter? The distance between them. Do you notice that? Why?
The frequency and the wavelength.
The wavelength is proportional to the x. Okay, yes. Red has a bigger wavelength. The wavelength is proportional to x. Wavelength is proportional to x. So wavelength rate, the x is now larger, the rate. Or if you take a blue color, shorter, okay, lambda blue shorter, then the x blue shorter also, like that. That's how it is. So this is the experimental setup lah, how it look like. This is better. You see how the diagram? So you ask me how the wave is going to meet each other, right? So if you look at this, maybe I make this bigger, better. Open up the... Okay, so you see how the wave are going to meet. This is a graphical representation. Of course, you can't see. Okay, you can't see the wave for the light, like lines. This is called wave front or planar wave. You see, they use the word planar wave, plane wave. We imagine the wave like that. We cannot see. If you can see, then it's good lah. You're very closer to God. So the wave is going to get diffracted. As they go through the slit, it is going to get diffracted. As they get diffracted, they're going to now cross one another. They're going to cross one another. So as they cross one another, they are interfering. They overlap and interfere. Superposition, they're going to follow the principle of superposition. And the effect of superposition is what you are seeing here, the fringe pattern. That is what is happening here. In order to happen, in order for this to happen, they must follow the criteria which I mentioned just now. Yes, the central maxima will be the midpoint. The central maxima is the midpoint, which I will explain why this happens, why there's a central maxima and how does this is related to the next part. That one is the next class. Okay. All right, so we'll stop here. Those who have questions can stay back and ask.